I'll go ahead and turn the first slide on. Thank you very much. Well, just a couple of opening comments. I certainly appreciate the invitation to spend some time in front of this group with some really top people who have worked in our government for a number of years on many issues of weapons of mass destruction. I appreciate the invitation. I'm actually a stand-in today. My boss, Colonel Ernie Takafuji, was supposed to give this talk on emerging infections, and he was not able to be here. So I also can thank him for being here with you today. I am talking today primarily about emerging infectious diseases, not so much from the biological warfare standpoint, but from an endemic disease standpoint. But since that really is not my predominant role in life in terms of what I do, I will make a few comments at the end of this presentation on the biological warfare defense issues. Can we have the lights down, please? Well, the topic of emerging infections has been in the news a lot recently in the last year or two, involving a number of different disease outbreaks or incidents. This is a New Yorker article published by Richard Preston a couple of years ago called Crisis in the Hot Zone, which details an event where Ebola virus was imported into the United States. And I'll go into that quite a bit more in a few minutes. He also wrote a book based on this event, which is called The Hot Zone, which is a current bestseller, and was supposed to be made into a movie, but the actors couldn't quite get their parts reconciled, and so the effort was dropped for the time being. I suspect it will be brought back, and I suspect the real movie about this event will probably be a lot more factual than the current movie that's out called Outbreak. This is a book that Laurie Garrett recently published called The Coming Plague, which is a much more scholarly look at the emerging infectious disease issue over the last 20 plus years, and I highly recommend it. It's got a lot of good factual information in it for your reading. And even Newsweek got on the bandwagon with an article on the Ebola virus scare entitled Killer Virus. So there's been a lot of press out there on emerging infections. When we think about emerging infections, just what are those? Well, they're diseases of infectious origin whose incidence in humans has increased within the past 2 decades or threatens to increase in the near future. Now, that's a pretty broad definition, and really, I don't think describes the issue of emerging infections very well, even though that's the definition that the U.S. Public Health Service uses. I think you can better describe the issue of emerging infections by dividing it into several different areas. The first would be organisms that have been in the environment, that have naturally persisted in the environment, but only make their appearance or are identified in random outbreaks, or maybe not so random outbreaks, with environmental or social changes. Then we have truly new organisms which have evolved as a result of adaptation or environmental pressures. This is actually fairly rare comparatively. Then we have organisms with new characteristics, old organisms who have developed new abilities to either be more virulent in human hosts or who have developed the ability to withstand some of the antibiotics that we have to treat them with. And then finally, the last category would be new or genetically modified organisms which may be a result of deliberate actions. And this speaks to what Dr. Wood was talking about earlier in terms of the biological warfare threat. This is the Ebola virus. It's called a filovirus, filamentous virus. It's a very, very nasty organism, and this is how it looks on electron microscopy. Now, this happens to be the Reston Ebola virus strain, which is not pathogenic for humans for whatever reason. This looks the same under the electron microscope as Ebola Zaire or Ebola Sudan, which kill a very high number of the people that those viruses infect. Okay, well, let's talk about some examples of those four categories that I just mentioned. Well, natural organisms emerging. Well, Ebola and Marburg viruses and also Crimean Congo hemorrhagic fever probably fit into that category. They've probably been in the environment in the countries where they tend to live for quite a long time, but for whatever reason they appear every once in a while. We don't know what the reservoir for the first two of those is yet. And still, despite our best efforts, we haven't been able to find that. That would help a lot in trying to control outbreaks of these organisms. Truly new organisms, well, probably HIV, although that's not so clear. Certainly, we've only known about HIV for about the last 15 plus years. Organisms with new characteristics are fairly numerous. E. coli 157, which causes a very severe bloody diarrhea, generally in children, can cause hemolytic uremic syndrome. There's a new E. coli called 0111, which recently was reported as causing an outbreak of hemolytic uremic syndrome and several deaths in Australia. So there are a number of those. Resistant bacteria such as pneumococci, enterococci, Staphylococci, TB. Those are probably the biggest problem for the United States right now. In some communities in the southeastern United States, in isolates from middle ear fluid of children, about 30% of pneumococci are resistant to the standard antibiotics that we've normally used to treat those infections. A lot of enterococcal sepsis that is only sensitive to vancomycins. There was even a report of an enterococcal organism, I believe from Connecticut, where the organism actually developed a need for the antibiotic, for vancomycin, so that on the plate where the antibiotic discs were, the only place where the organism grew in a lady who had fulminant sepsis was around the vancomycin disc. And then the infectious disease doc was faced with the problem of, this lady was dying. What do? Do I take her off her antibiotics? He did, and she survived. So this is pretty scary stuff. And then the genetically modified issue, I'll address that a little bit later on. What are the factors that contribute to the transmission of infections in human societies? Well, they're numerous. Our behaviors, sometimes even our sexual behaviors, technology and industry, economic development and land use. International travel is a biggie. The fact that these organisms can now move from continent to continent really within a matter of hours if the host that happens to harbor them travel on an international flight. And several other factors. Breakdown of public health measures is a big deal in the third world, particularly in Africa. That's really been exhibited very well in Zaire in recent months, because Zaire, according to the people who have been there and know what Zaire is like, there's really not much of a functioning government there. And so the public health infrastructure of that country is very poor compared to what we normally would expect in the Western societies. So that contributes to the spread of diseases when they occur, such as the recent Ebola outbreak in Zaire. What other factors influence the emergence of these infections? Well, we have host factors, our own body's immunological competence. We have agent factors, their virulence and infectivity, how they're spread from person to person. Obviously, an agent that's spread by the airborne route, like the common cold or the flu, has much different implications epidemic-wise than an agent that appears to be mostly spread by close personal contact. And so that's a factor that's very important. And then environmental factors may also play a role. Microbial drug resistance may develop in one of two ways. It may develop in response to normal adaptation of the microbe, or it may develop in response to antimicrobial pressure, overuse of antibiotics. And so with more and more use of antibiotics, selective colonies of organisms develop resistance and are able to survive. And resistance is seen across the board with all types of organisms, not just bacteria, but also viruses, protozoa, etc. Now there's a difference between microbial drug resistance and microbial traffic. Resistance is an inherent ability of the microbe to withstand antimicrobials, whereas microbial traffic involves transfer of the agent to different populations. And as I mentioned before, there's a lot of good ways nowadays for microbial traffic to occur with international travel. And several recent good examples. I think someone this morning mentioned the cholera cases on the flight to Los Angeles from South America, the recent exposures on airplanes of patients or of passengers to a patient with active TB. So international travel does contribute to the spread of both common and exotic infections, and there's a potential risk for not only transmission to others, but introduction of organisms into new populations. International control measures are not likely to be effective. I don't know how many of you, at least the standard measures of coming through customs, are not likely to pick up too many people with infections that they're carrying, unless there's some heightened awareness, such as occurred maybe with the Indian plague outbreak. So a lot of factors promote this. A lot of factors promote the fact that people are more likely to move around in the world today and carry their flora and fauna with them. Now, from a military standpoint, we also have to deal with this. And it's probably more important to us on a routine basis than worrying about the threat of biological warfare, just because we deploy lots of soldiers, sailors, and Marines all over the world. And they are exposed in hostile environments to all kinds of different diseases that they are essentially virgins to. And this is, I really don't have to go into this in detail because many of you probably in the past even have been involved in military deployments where disease occurred. And as we move around the world, we get exposed to things like malaria and dengue, and we see this every day in our active duty military population. So the risk is really there, and the conditions may promote transmission of disease, and the military represent a really highly susceptible population in these exotic areas. All right, what about routes of transmission? How are these agents transmitted from person to person? Well, the reason we have such problems with controlling endemic diseases is because they have a number of ways to be transmitted to us. And many of these are, you can just cite numerous classic examples. Fecal oral is probably one of the greatest ways in the world where disease is transmitted. Cholera is a perfect example. Airborne and respiratory spread, influenza. Contaminated blood, Ebola. Vectors in animal hosts, dengue, malaria. Contact with contaminated environment. A lot of the enteric diseases fall in there, and even percutaneous and mucosal contact. Here's some of the epidemics that have occurred in the world in the past, and who knows what we're going to be faced with in the future. Probably some of these things are going to continue to be problems for us, and others will come about that are not necessarily on this list. What about emerging infectious disease threats, though? What are some examples of those that are occurring in the world today? Not just your normal routine diseases, but the new ones. Well, we've got our hemorrhagic fever virus problem, Lassa, Ebola, Marburg, multiply resistant Mycobacterium tuberculosis. New and virulent strains of strep pyogenes. Group A strep, these so-called flesh-eating bacteria have been with us for a long time. Strep fasciitis has been around ever since, I know since I was in medical school and long before. And it's just recently that there have been a number of outbreaks of this disease that have brought it back into the limelight. Methicillin-resistant Staph aureus, the hemorrhagic E. coli 157 colitis, and new forms of hepatitis C and E. HIV and other retroviruses. Drug-resistant leishmaniasis, which we've seen in our military populations recently. That's one of the few things that we've actually been able to diagnose in Gulf War veterans, is the leishmania problem in a small number of those people. Resistant malaria. Mefloquine-resistant malaria is popping up all over the world. Antibiotic-resistant organisms in this country, as well as other places, and new strains of cholera. In the Americas, on this side of the Atlantic, you can see some of the ones that have occurred here, and many of those are on the list you just saw. One that I didn't mention before is the hantavirus pulmonary syndrome in the U.S. that occurred in 93 and 94. Human ehrlichiosis in the Midwestern U.S. is a fairly new problem. Well, you know, we've gone through kind of a laundry list of the different types of emerging infections. Now what I'd like to do is just give you an idea of how we at the Army's Infectious Disease Institute, USAMRIID, have been involved with or dealt with some of these emerging infectious disease issues in the recent past. We don't just deal with biological defense. We also deal with endemic disease as well. Here are some of the things we've been involved in the last few years. There was a Marburg case in Sweden in 1988 that we helped out with. There was the Ebola introduction into Reston, Virginia in 1989. The hantavirus situation in the Southwest in 93. There was a case of a new hemorrhagic fever virus, Venezuelan hemorrhagic fever virus called Sabia, which occurred at Yale at a research facility last year. And finally, the Ebola outbreak that you've heard so much about, that it just occurred this year in Zaire. The Marburg case in Sweden involved a patient who basically imported this case out of Africa, was hospitalized in a Swedish hospital, and by the time they figured out that this person had a hemorrhagic fever virus on board, she was too unstable, too sick to transfer. And so our involvement was to go over and advise them on containment care and help them set up the procedures within their hospital that would help to minimize exposure of the staff to infectious secretions and try and help her get well while preventing further spread of the illness. Again, this is a virus which historically has a case fatality rate of around 70–80%. Now, Ebola virus disease has occurred in a number of places. It's a severe, often fatal hemorrhagic illness documented in Sudan and Zaire in the 1970s with a case fatality rate of between 65 and 85%. Transmission, we have recently shown at USAMRIID, can occur, at least in primates, by the airborne route. But in human outbreaks thus far, primarily the people who have become ill, even in the situations in Africa, have been people who have had direct contact with secretions of the patients. So that is important information. Non-human primates are highly susceptible. In fact, they're so susceptible that we do not believe that monkeys are the primary reservoir, because monkeys get too sick too fast and die from this infection. So there's another reservoir out there harboring this organism which has a more commensal relationship with the organism and can survive. A reservoir of a host is not a reservoir of an infectious agent has to be able to allow that infectious agent to continue to survive. And monkeys die too fast. The incubation period of Ebola is between 4 and 16 days. Symptoms include symptoms that you would normally see with just about any viral illness initially. Fever, headache, malaise, body aches. But subsequently, severe hemorrhage occurs, as well as severe mental and neurologic symptoms often, including seizures. And these often precede death. There is no definitive treatment for Ebola. Ribavirin, which is an antiviral drug which does very well against a number of the viruses like CCHF that we know about, has no effect on this filovirus. And prevention is based on quarantine and isolation procedures and avoidance of contaminated materials and also avoidance of needle contamination. That's one of the big factors that's caused the spread of the epidemic in Zaire, because they reuse needles in that part of the world. It's a significant infection of military importance. There has been some talk today already about the fact that some of our adversaries may be working on this agent for other means. And that is a significant concern because it's such a bad actor. Sorry, I'm going the wrong way. Here's the history of the filoviruses in man. The first known outbreak was in '67 with Marburg in Germany. A number of people died there from that virus. And then in '76, Ebola Zaire occurred in Zaire, Africa, actually in northern Zaire, fairly far away from where the current epidemic is. Then in 1979, there was another Ebola outbreak in Sudan, followed very closely by some more Marburg cases in Kenya. Much of these outbreaks were nosocomial spread within the hospitals. Then there was a hiatus for about 9 years, and we didn't see Ebola again until it showed up in Reston, Virginia, at a monkey quarantine facility. Subsequently, there's been an isolated case of an even different and newer strain of Ebola in Sierra Leone in Africa, in an ethnologist who was working with primates. Now these are monkey cages, African green monkey cages, that were used to import animals for scientific research into the U.S., where they were quarantined at a facility in Reston, Virginia, which is in a nice suburban community just south of D.C. In 1989. And what happened was that monkeys in this facility started to die. And the veterinarian who was responsible for the facility initially thought that this was an outbreak of simian hemorrhagic fever, which is a common virus in primates. And initially, the folks at USAMRIID, who were asked to consult on the case, thought that's what they were dealing with too. In fact, they cultured that virus out of the primates. But a few days later, they also cultured or found a different virus. And that was this filovirus, this stranded virus that I showed you a picture of a minute ago. And that was a real shock. That was Ebola in the United States. And our scientists were stunned, to say the least. Maybe not so surprised, but still stunned. So what happened after that? Well, immediately there was a major public health effort that was mobilized, which included the Army, the State Department of Public Health in Virginia, the CDC, and a number of other agencies. And a plan was worked out whereby the folks from USAMRIID, where I work, along with the help of the CDC, went in and basically quarantined that facility and decontaminated the facility and sacrificed all the sick animals to contain the outbreak. Tremendous worry about this virus getting out into the local civilian population. This is the back of the building, pretty nondescript building. And this is the man who led the expedition to basically decontaminate the facility. Jerry Jacks Colonel Jerry Jacks, who's chief of our veterinary medicine division, and you can read about him and his wife, Colonel Nancy Jacks, in the book The Hot Zone. And this is the kind of suits, Raycal protective suits, that our personnel wore into that facility, and used these syringes mounted on long sticks to basically anesthetize the animals and then deal with them. It's very, very dangerous work. Colonel Jerry Jacks tells the story of when they initially went into the facility in these suits. He ran face to face into one of the animal handlers who worked in the facility, and the animal handler was dressed like, well, maybe not like you or I are, but dressed in civilian clothes, no protection. And Jerry said he looked at him and he looked at him, and he said, I knew one of us was really wrong. So anyway, they went in there and they got the job done. They basically were able to fully decontaminate the facility and take the animals back up to USAMRIID for pathologic diagnosis. And this was accomplished over a matter of a few days. And at USAMRIID, we have the specialized capabilities, BL4 laboratories, to be able to deal with tissues and specimens like this that are infected with these very, very high hazard agents like Ebola. This is Dr. Peter Jarling, who is our senior scientist, and he was the lead scientist on this effort to contain the Ebola outbreak. Now, how did this happen? How did Ebola get into a facility in Reston, Virginia? Well, we don't really know the whole story. The part of the story that we do know is that, let's see if this thing works here, that we know that these monkeys originated at a monkey facility in the Philippines. And they went through Amsterdam, and they ended up at JFK, and then finally to the DC area, where by federal law they have to be quarantined for a period of time to make sure they don't have any infectious problems. What we don't know is really how they got to the Philippines in the first place. Did they come from Sudan and Zaire? We don't really know that, but that's what is suspected, that they made their way from Africa, where this organism has only been found in nature, all the way to right outside of Washington, D.C. So, the lesson here is that, yes, in fact, these agents can travel long distances and can show up within our shores. Now, the good part of this story is that it turned out that even though several of the animal handlers who worked in this facility became seropositive, had an antibody response to Ebola Reston virus, none of them became ill. And so for some reason there's a genetic switch in this organism which makes it different than Ebola Zaire or Ebola Sudan or Marburg. It does not appear to cause severe human disease. Now, do we still work with it under BL4 conditions? You better believe it. All right, the next issue, just to mention briefly, is the hantavirus pulmonary syndrome issue that occurred in the U.S., in southwestern U.S. in 1993. Now, this was an old virus. Hantaviruses have been around forever, and they've caused a syndrome called hemorrhagic fever with renal syndrome all over the world. South Korea, Europe, Russia, number of places. But the pulmonary involvement with this virus, with severe pulmonary involvement leading to adult respiratory distress syndrome and death, is new. That's what's different about this one. And in this outbreak, you can see where the cases were, and they were in a lot of different places in the U.S. There's even been cases reported as far away from the Four Corners area as Florida, and one up in the northeast area. So there are reservoirs and hosts that can transmit this virus literally all over the country, although it appears that they're primarily concentrated in this area. And something about the ecology of this area caused this disease to come out. Whether it's the food supply for the mice that harbor the organism or what, it happened. Now, it's interesting to note that if you look back at pneumonia cases from the late 60s in the United States and mortality from pneumonia, it's interesting to note that this area lights up back in the 60s. Now, could that have been due to HPS? Possibly. So this may not be really a new emerging disease. It may be an old disease that we've just recognized. The fatality rate, and this is a busy slide, but I just put it in here to show you that about 54% of the cases up until August of '94 died from this syndrome. Now, very briefly, another incident we were involved in, there was a scientist working with Sabia virus, which is a South American hemorrhagic fever virus, up in Yale at New Haven in a research facility there. And he was working with a centrifuge, and he was spinning down some samples, some cell cultures containing this virus. And he opened this contained centrifuge and noticed that one of the tubes had become broken, and there was solution in the bottom of the centrifuge and on the bottle. And he subsequently put on gloves and a surgical mask and cleaned that up using paper towels. Didn't tell anybody. Well, about 4 or 5 days later, he started getting sick. He started coming down with fever, chills, malaise. He went to the hospital at New Haven and was hospitalized, and he told him that he thought he had malaria because he had had Vivax malaria in the past and thought this was a recrudescence of his Vivax malaria. Did not, again, tell them initially about the accident in the laboratory. It was only upon further questioning that he remembered this incident that had occurred in the laboratory several days before. In the meantime, he had exposed like 30 or 40 people during his incubation period to himself in several areas surrounding that geographic area. So basically, the end of the story is good. Again, he was treated with IV ribavirin, which is effective against this virus. He defervesced, he did well. None of his close personal contacts became ill. So this created quite a lot of press and also created quite a problem for that research facility, even to the point where they thought they were going to have to close it down. We were involved because we have a special team that can evacuate patients like that, which I'll show you in a minute, where we were on call to evacuate this guy down to USAMRIID and contain him within a BL4 containment area and treat him under containment conditions. But because he was getting well by that time, we never had to go get him. Now finally, let's talk a bit about Zaire. This is a map of Zaire. Here's Kinshasa, the capital. Kitwit, where the outbreak primarily occurred, is about 300 miles southeast, not on this map, of Kinshasa. Oh, let me just mention too that the previous outbreak in Zaire occurred up in this area, near the Ebola River. So this virus struck in Zaire actually started back in January, even though we didn't really find out about it till April. And basically, Zaire, this quote is very true. Ebola strikes Zaire's vulnerable heart. Well, with the lack of infrastructure in Zaire, this virus has the propensity to just run wild. Nosocomial spread because of poor hygienic techniques, reusing needles, not even the normal barrier protections that we would expect on a routine basis in our hospitals. In this outbreak, there have been, as of June 25th, 296 cases, which puts it at the top of the list in the African outbreaks with about an 80% mortality rate. The mean age is about 37 years with a large range. In Kikwit, there have been almost all of the cases. There have been 5 or 6 other towns around Kikwit where there have been an additional 48 cases. This actually started, it was recognized first on April 9th in a 36-year-old laboratory technician who became sick with a fever and the type of symptoms that I've described to you. He was thought to have an abdominal surgical process and was operated on 10th of April. And 13 of his contacts in that hospital, mostly healthcare providers, subsequently died from the virus. The earliest case may have occurred around the 9th of January in a charcoal worker who lived near Kikwit but was working at the edge of the forest. And he may have been the one who started all this off. That's still a matter of some conjecture. 70% of the first 70 patients were healthcare workers, and 32% overall, even after measures to prevent nosocomial spread were instituted. The epidemic curve is now in the 4th generation, but the disease is now smoldering. There's only a few isolated cases occurring, but enough isolated cases to indicate that there may be still ongoing transmission of the virus from the reservoir, not person-to-person spread, to new cases, whatever that reservoir is. And now they're using convalescent blood from patients who are getting well to treat the cases who are sick. This is obviously kind of dangerous, especially if you're dealing in an area where there's a high propensity to be HIV positive, as well as other more mundane issues like transfusion reactions and that sort of thing. But that's been very successful. 8 out of 8 patients where this has been used, 7 have survived. Here's the signs and symptoms, mainly what I've mentioned to you before. Fever is almost always present. Bleeding is only present in about 38% of the cases. And why hiccups? You got me. In terms of intrafamilial spread, what they've found in the cases where they've looked at that is that of 78 household contacts who had no direct contact with the secretions of the primary cases during their clinical illness, none of them have gotten sick. The ones who have gotten sick have been people who have gone to see their family members in the hospital, shared the same bed, been very close to them in terms of their body secretions. Now, another thing that may be promoting the spread of this virus in Zaire is the fact that there's been some conjecture about could monkeys be infected with this virus and transmit this virus through eating monkeys to the population. The monkey is considered a delicacy there, and the population will often make, the people will often make monkey stews. And so that is a matter of some concern that people may continue to become infected through that route. Dr. Nancy Jacks at our institute has shown that in 4 primates given Ebola Zaire by the oral route, all of them came down with clinical illness and died. It's also infective by the conjunctival route and also can be transmitted from monkey cage on one side of the room to monkey cage on the other side of the room through the airborne route. So very scary infectious virus. And again, I want to make sure this message gets home, however, primarily in the human outbreaks, most of the cases have been nosocomial with person-to-person spread through direct contact. We also have sent a team along with the CDC into the area to try and determine what the reservoir is. And the team from both institutes has captured any number of animals that they've attempted to try and find if the virus was harbored by these animals, including things like the snake right here. Now, I'm not sure I'd want his job, but that's the kind of thing we're doing to try and find the reservoir. The reservoir has still not been found for all of these hemorrhagic fever viruses like Marburg and Ebola. This is Katoum Cave, in in Kenya, and this is where one of the Marburg cases occurred back in the 70s, and there's been an extensive search of this cave for a reservoir, and so far it has not been found. Another way we've supported the operation in Zaire is through our aeromedical isolation team. We've been on a 6-hour alert to go to Zaire to evacuate any American casualties that might become ill during their work with the effort to control the epidemic. And the Air Force would support us in going there using a C-17 aircraft that would be refueled mid-air in a 6,800-mile flight. The receiving medical facilities would either be one of our Army medical centers in Germany or our isolation suite at USAMRIID at Fort Detrick. This is what our aeromedical isolation team looks like. Basically a large isolator, adult size, where it has ports where you can start IVs and take care of patients basically as you would an infant in an incubator. This shows the team bringing one of the isolators off of Air Force aircraft. We also have the capability at USAMRIID to care for patients with these illnesses under BL4 containment conditions up to an ICU level of care. And that's with supplementation of medical specialists from Walter Reed, which is our local medical center about 40 miles down the road. Now finally, just to mention, Dr. Wood has already piqued your interest on the biological warfare issue, and I don't want to steal the thunder of the speakers tomorrow who are going to speak on this issue, but just to mention that we also are worried about the use of some of these agents to intentionally cause disease or illness in either civilian populations or in our military troops. Biological weapons do constitute a significant threat. The one area where I would disagree with Dr. Wood on just slightly, and I agree with him that biological weapons are not good weapons for use against fast-moving tactical military forces. However, the supporting force, which is 6 times the size of the fast movers, is generally in rear areas and stationary. You cannot move an Army evac hospital unless you have 127 flatbed trucks. So once it's put in a place, the tendency is to leave it there. And so it becomes a stationary target. And BW weapons are good weapons to use against stationary targets. So in that sense, they would be potentially good military weapons of mass destruction. But his point about civilian casualties, totally unprotected populations, is certainly very well taken. Now these include naturally occurring organisms, or they may include bioengineered or modified organisms. I think his point also is correct that the ones we worry about the most would be the classical agents, things like anthrax, plague, botulinum toxin, things that the US and the Russians worked on in the 50s and 60s. These are not new agents. Now, just to give you a little idea of the casualty potential of these agents, and if we could focus that slide just a little bit, please. I want you to look at the last line of this slide. This is a hypothetical dissemination by airplane of only 50 kilograms of anthrax along a 2-kilometer line upwind of a population center, city or otherwise, of 500,000 people. Now these are estimates done back in 1970. Anthrax under ideal weather conditions would go much further than 20 kilometers downwind, and this invisible cloud would be enough to, within the first 3 days, in unprotected populations, kill close to 100,000 people, and in the next few days, well, in those first 3 days also would incapacitate another 100+ thousand people. And in the few days after that, because anthrax has about a 80 to 90% case fatality rate, most of these folks in the incapacitated column would move into the dead column. And that would include your politicians, your healthcare providers, whoever happened to be in that area. So we're talking about a true weapon of mass destruction that requires not that much technology to deliver. You can do this with an off-the-shelf agricultural sprayer. This is the laboratory at Salman Pak in Iraq, an hour south of Baghdad, where the Iraqis were working on anthrax, botulinum toxin, and Clostridium perfringens. That's not classified, that's been in the open press. And I talked to Dr. Taha, who was the scientist who was running that program, and she confirmed those press reports. Now, it doesn't look like much now because we bombed it during the air war, but you can go in there and see that this was a facility that was the equal of any facility technologically probably in the Western world. Now, the terrorists also know about this stuff. Here is an incident back in March of '92 where a man walked into the living room of this house in Fairfax, Virginia. For some reason, Virginia seems to attract a lot of this stuff. But he walked into this house in Fairfax, Virginia, and a bunch of his neighbors were sitting around a table talking. And there was an ashtray in the middle of the table, and he took a vial of an amber-colored liquid and threw it into the middle of the table, breaking it and splattering the contents around the table on the people sitting there. And he stated to his neighbors, "This is anthrax, you're all going to die." Well, he was not too popular in the neighborhood after that. They called in the hazmat teams. The police came in and cordoned off the area. About 40 people from that neighborhood showed up at Fairfax Hospital Emergency Department, and I got a call from Dr. Tom Mayer, who was head of the emergency department there, and we had known each other from past lives, and he said, "Ed, how do I take care of these folks? What do I do? Do I put them on antibiotics? Do I quarantine them?" There was a tremendous amount of consternation about this small event. And I use it to highlight the fact that a large event using biological agents would be a major public health effort. It would not be a small thing. This has been driven home recently by the sarin incident in Japan in the Tokyo subway, and it only serves to make us remember that biological terrorism, or chemical terrorism for that matter, could occur and is likely to occur sometime in the future, and we must be prepared to deal with this threat. The response, what is the response? Well, like I said earlier this afternoon, there is a light at the end of the tunnel. It appears that our government is finally being turned on to this issue, and there are people within the Public Health Service and other branches of our government who are coming together to try and mount a response on a local basis in our major metropolitan areas to counteract this potential threat. This is being run out of the Office of Emergency Preparedness at the Public Health Service, which is run by Admiral Frank Young. New initiatives are very likely in the area of training, incident containment, and consequence management. So I'll just end up by showing you a couple of quotes from a couple of famous people. Josh Lederberg said in 1989, "Nature isn't benign. The survival of the human species is not a preordained evolutionary program. Abundant sources of genetic variation exist for viruses to learn new tricks, not necessarily confined to what happens routinely or even frequently." And finally, Colin Powell said to the Joint Chiefs of Staff in March 1993, "I'm confident that we can defend against chemical warfare. The one that scares me to death is biological warfare." So the question now remains for all of us, both civilian and in the military, especially us healthcare providers, is, are we ready for this? Be happy to take your questions if we have time.